Hello, I'm Scott Murray, and this is Lessons Learned from the AGL Development Platform. A little bit about myself. I've been a Linux user and developer since 1996. I've been an embedded Linux developer since 2000. I'm currently a principal software engineer at Konsulko Group, and Konsulko is a software services company specializing in embedded Linux and open source software. We do hardware and software build, design, and development, and offer training services. The company is based in San Jose, California, but it has a distributed engineering presence worldwide. There's the website there. We've had a contract to do AGL development since probably early 2016. I've been working on it since late 2016, and I've done a bunch of development for the application framework bindings for various services, as well as build and demo support. A little bit on the agenda for this talk. I'm going to run through the demo platform history, go a little bit more detail into some of the recent software development, and talk about some of the limitations for the current demo platform, some of the potential future development we're going to do, and then I'm going to kind of run through some lessons that working on the demo platform has sort of given me about what it would take to productize AGL. And then some quick closing comments. So this picture is of the original quote-unquote Green Machine demo platform from 2016 and 2017. Was based on a Renesas Porter board with an ARCAR2 system on chip. I believe it was used at both ALS 2016 and 2017, as well as CES 2017. The CES 2017 demo was based on Charming Chinook, the Universal Code Base 3, and it involved a lot of the initial conversion of things to the, at that time, new application framework. It did actually have a binary image for a cluster demo, as well as most support from Microchip and HVAC demo support. There's a video that Dan did for CES 2017 that's at that link there that actually runs through a lot of the demo features at that time. So that was 2017. I'm going to quickly jump to the more current demo platform. This is the newer Green Machine. And so this was built for AGL, at least the chassis, by Panasonic in late 2017. And the hardware platform was switched to ARCAR3 based the M3 ULCB with the Kingfisher daughter board. And I believe the Miniboard Max was kept on. It was the same cluster board as had been used in the previous demo system. And at that time, an additional MOST component was added. Fiberdyne provided a beta version of their MOST amplifier. And this was used starting at CES 2018. So that demo at CES 2018 was based on the Electric Eel release, which at the time was 5.1. And the cluster demo there was still running the binary demo image that had been provided by someone. There had been a lot of development work late in 2017 in that run up to CES. There was a new window manager. The 4A audio framework had just come in, and the switch over to the M3 ULCB and the Kingfisher. That was all sort of arrived in the last couple of months of 2017. So that was sort of the state of things through all of 2018. And at CES 2019, the hardware was roughly the same. Still had the Miniboard Max as the cluster. Microchip had renamed MOST to a NICNet, I think, but in this time frame, and so at that time they had provided their initial samples of the microphone that they have offered up for AGL development. The CES 2019 demos were based on Funky Flounder, the 6.0 UCB release. And that time we actually swapped out the binary cluster demo with an image for the Minnow board built with the new cluster profile. I'll go into more detail about that later. And at that time, at CES, were 3 demo setups at CES 2019. There was the stock demo based on upstream UCB, There was a demo of Amazon Alexa integration, and I'll go into some more detail about that later as well. And as well, there was an advanced demo that has been referred to as demo 3 or demo number 3 at a couple times in various places, which wasn't running on one of the green machine setups. It was on a dev board based setup, and it was showing off an enhanced window management and a cluster that was quite different than the stock one, and had a landscape format setup. So to continue on into 2019, the M3 ULCB was replaced with H3 ULCB in the demo systems and for a lot of AGL development. And I believe we actually switched at ALS 2019. And as well, the most slash INICNet hardware was replaced during the year with new Rev B boards, with the new interconnect and phantom power support. Ian Simone did some work and switched the demo unit power to internal rail mount power supplies to really simplify setup and internal cabling. And the cluster navigation streaming for the cluster, basically to stream the map data over, was reworked for the AMM in the fall of last year. And so that work actually brought back code from the advanced demo. There had been some forking done for that demo setup, so brought some of the changes back. And this was sort of required because the previous GPS Navi had been obsoleted at that point. I'll go into a little more detail about that as well later on. So where are we at today? So the CES 2020 demo hardware was again roughly the same from the outside. It's H3 ULCB with the Kingfisher, still with the Green Machine chassis. We replaced the Miniboard Max with the Raspberry Pi 4s for driving the cluster, just because the Raspberry Pi 4 is a newer board with the AGL support, and the Miniboard Max is less available these days. It's somewhat discontinued, so it's better to sort of demo something that's available. As well, a steering wheel demo was integrated. Suzuki provided some steering wheels, and Microchip provided LIN adapters to integrate them. And the CES 2020 demo was based on Happy Halibut UCB 8.0, which is I guess at this point is still maintained. It's the oldest maintained release because Icefish is now out, and Jellyfish is soon to release. One of the key demo features for this year's CES was upstream Amazon Alexa integration. I'm going to go into some details on that. Switch to Pipewire and Wire Plumber as the audio framework. And this year's CES, there were two separate demo setups. A stock demo, same as 2019, and a demo of containerized IVI and cluster images, both running on the H3 ULCB as opposed to having a separate cluster board. Jan Simone and Walt actually start in this video that's linked here from Embedded World Congress, where they run through the demo and discuss quite a bit of the AGL project benefits. Okay, so some of this work that was done in 2018, 2019 to make the demo kind of work for CES. What does that consist of? I'm going to run through these sort of 5 high-level tasks and go into some detail of what was done to kind of integrate these various things. So the first is upstream demo support. So at CES 2019 was the sort of goal to actually have a stock demo, which was basically something that was built directly from the UCB source tree, didn't require any manual additions or modifications, and was quite reproducible because there had been previous conferences and trade shows where things were sort of put together by hand, and it was very difficult to keep track of what the current state of things was. So this, improved reproducibility, and also kind of helps AGL testability, because then we can actually say, well, this demo system is actually buildable, and you can do tests, and we can compare what people see. And so part of that, also is to reduce effort for getting prepared, for setting up at different shows. and as well as, especially with 2019, demonstrating the addition of the new profiles for like the instrument cluster, and a bit this year at 2020 for the telematics. One of those big things that I mentioned earlier was the instrument cluster being re-implemented to replace the sort of binary proprietary image that we had been using with something that was upstream and open source. That was kind of one of the big first development to try and move the demo system to being upstream. And as well, right around that same time frame in late 2018, we added the AGL demo preload and cluster demo support features so that you can configure a demo image that looks a lot more like the green machine for testing. And it's basically how we build the images for taking to CES or ALS. And then later in 2019, for this year's CES, we sort of targeted actually getting more of the Alexa support upstream and integrated to kind of make it so that the demo was more turnkey for that as well. So to expand on the cluster support, so as I mentioned, the original Metaboard Max image was provided by one of the AGL members. The streaming of the nav was kind of ad hoc. The Hitachi and Eisen provided map viewer application for the streaming is basically a cut down version of the original GPS Navi app, and it's pretty much hand coded GL application, and the streaming was actually done with the Renaissance specific GST record addition to Weston, and there were some shell scripts and things involved. It was sort of pieced together by hand. So for CS 2018, that was kind of replaced with an image built with the cluster profile, this AGL cluster demo platform image that you can build. And it has application framework based replacements for that binary image. And so there's a dashboard and a stream receiver for the navigation data to do the map. That's all in UCB, and you can build those images if you want to set it up yourself. And then in 2019, so for the AMM last year, so GPS Navi had been obsoleted, as I mentioned. And so the demo 3 for CES 2019, the advanced demo, was running in a Mapbox data using Qt location based nav app. So we repurposed that, and it actually had a cluster app that also was repurposed. And the GST record feature in last year was basically replaced with an upstream feature in Weston called Weston Remoting. So I did a bunch of rework to kind of hook all those pieces together to give us something that looked roughly the same as the original demo, but used things that we have the source code for and is all upstream. So the next sort of thing that has been done, work was done for this year's CES, as I mentioned. So the Amazon Alexa, the original integration was done for CES 2019 by Amazon and ICS, with quite a bit of assistance from the IoT BZH developers to help them get going and debug things. The voice agent widget they built for the voice framework up until later last year lived out of Tree, and the build process for it was somewhat involved. It took some effort to reproduce. As well, the Alexa Auto SDK gave us a lot of issues, even at CES 2019 and all the way through ALS last year. The 1.6 version, its authentication support was very shaky on the Linux. And it was very hard to actually get it booted up and work reproducibly. And in addition, the ICS demo apps that were used at CES 2019 were binary only, and they weren't in a position to give us the source code for them. So they kind of became obsolete somewhat early last year with some voice core changes. So to kind of get us that we had something to demo for CES 2020, we started on some work to actually upgrade to Alexa Auto SDK 2.0, rework of the the core binding to actually make it so that the Alexa voice agent is optional. It was sort of baked into the configuration originally. And that kind of makes it easier to build the support into things like home screen all the time and not have to have a bunch of conditional things. We can basically drop the voice agents on top and they'll get picked up at boot time. So at that time we added a AGL voice agent Alexa feature so that you can configure to build the voice agent. When you do that, it actually pulls in the SDK and builds the voice agent. And sort of later in the year, we added a wake word configuration feature. If you actually do have the binary wake word engine, you can actually set things up to actually pull that into your build and use it. We were using that at CES 2020. Late in the year, like right before CES, basically, because we didn't have the ICS applications, I did some development to build a quite simple Alexa response viewer, which uses the VSHL capabilities binding responses, which are basically coming from the Alexa voice agent. That involved actually a surprising amount of debugging of some of the app framework usage in the Alexa voice agent, which was a bit of a surprise, and I'll talk a little bit later about what that means for people down the road. But that's actually all reproducible. You can build that and play with it yourself. So the other big thing in late 2019 was Pipewire and WirePlumber. So the work started in the fall to sort of replace the 4A usage with Pipewire. They're still under active heavy development even now. I mean, back then it was pretty straight development for the developers from Collabra. So George and Julian put a lot of effort in December to actually get that all sort of working for CES. One thing to note is we did actually have to do some work for modifications to work with the WirePlumber policy and some of the applications. That's something that we still have some open discussion about. It's not clear whether that's a long-term thing or not. And there are still some open policy issues with respect to Bluetooth, especially around voice calls with the hands-free profile. If you're curious, that's actually the spec number there for it. So the next big thing that was actually quite, interesting to see people come up and play with from a demo perspective is steering wheel integration. As I mentioned previously, Suzuki provided steering wheels. Michael Fabry from Microchip basically coded up some firmware and made a LIN adapter to actually make these analog steering wheels work with LIN. The adapter was wired into the LIN network with the existing HVAC LIN controller. And one of the changes for CES 2020 was we switched to using USB UART to hook up the LIN transceiver. Kind of simplified our cabling and made it easier to test some of these things without necessarily having to have the whole demo set up. Kind of makes it a little easier to just have the LIN adapter and the LIN transceiver and just do some testing manually. The LIN event polling for the steering wheel was driven with the LIN config utility, which is a bit of a older, less known thing. There's some potential development down the road to maybe shift that into maybe the low CAN binding, but at the moment it works reasonably well. The steering wheel messages for the LIN events were added to the low CAN bindings AGL vCar definition, which is sort of the default that we use for the demo system. And then I actually went up and added virtual button events in Signal Composer to sit on top of those CAN messages to provide an extra layer of abstraction, which would make it easier for someone else to set up their own demo with a different steering wheel type device. It should be easier to wire that up with like a USB steering wheel and not have to recode things in applications. Part of the demo was actually driving indicators on the cluster. We did some work to add some more logic in the cluster to be able to trigger changing icons. And it's a bit of a hack that I did. I basically am using CAN dump to bridge the CAN messages that come from the LIN devices over to the primary CAN interface. So basically, in low CAN, I'm bridging the low speed CAN over to the high speed CAN so that the cluster board will see them. It's actually less than ideal. We're going to have to come up with something better. I'll mention later roughly what the plans are there. So that's kind of the recent development, just, in general, the things that have been done in the last year and a half, the big items. So where are we left with the current demo platform? What are our limitations? So there's definitely, when we're running at CES or one of the other shows, there are things that happen that are not entirely ideal. One of which is tends to happen a couple times a day usually. The Fiberdyne amplifier sometimes just drops off the NICnet and requires restarting the Unisense service or rebooting potentially. And because we have beta hardware, it's likely just a beta hardware limit. And so there has been some discussion around potentially switching to microchip, have newer output boards, but they don't actually do much in the way of amplification. So when we were trying them previously, it was hard to get a lot of volume out in like a CES environment where it's quite noisy. So there's probably some future thought has to go into what we'll do about that. As I mentioned, my LIN to CAN bridging hack previously, it's less than ideal in that it sometimes hangs. I'm not sure why CAN dump gets unhappy, but it just gets stuck. So probably I'll think about either doing a signal composer sort of version of that, taking the LIN events and translating them into either new CAN messages to send out or into something else, or maybe a dedicated like event binding of some kind for the steering wheel. I'll have to put some thought in and do some experiments to see what would be the best way to go forward. The IVI to cluster CAN connection, so what I'm bridging the LIN events over to, sometimes goes into error state in our setups that I've wired up for testing here locally and at the CES. And so we have been using a simple Python script to sort of be a little vehicle simulator. And either the CAN events it's sending, the CAN messages, or the LIN bridging seems to sort of provoke the CAN interface going into error state. And it's a bit tricky to actually get out of that. You have to restart several things. And there's definitely more investigation required. It's really not clear why that could be happening. So that's probably in the near future, I'm going to get back to doing some investigation of that. The Raspberry Pi 4 that we started using for the instrument cluster at CES, especially because it's running inside the green machine, it did start to get a little hot. The Pi 4 runs quite a bit hotter than the older ones. Even with a significant heat sink on it, we did see, I think, at least once where it basically just hung up and the cluster display stopped working until it was turned off for a bit and cooled down. So we'll have to think a bit about that, what to do around cooling or switching to some other board that we have good support for in AGL that makes for a good demo. And the other sort of big thing is it has been probably for at least 2 years quite challenging to demonstrate Bluetooth. The Kingfisher Bluetooth hardware, the onboard antenna seems to not really give you much range, and that makes it sort of compounds in like trade show environments where there's a lot of RF noise and a lot of people with devices that are actively doing Wi-Fi and Bluetooth. It really is. You need a quite good setup to actually make it work well in that environment, unless you're doing a very simple demo where you're not trying to do anything too complex. And the other issue that has sort of been dragging on is that audio policy has been somewhat problematic. As I mentioned earlier, Pipewire, there's still some open issues there. So it is difficult to actually do things like voice call demos. Future development. Folks who've been following the dev calls and mailing lists the last few months probably have seen there's a new compositor coming in, Jumping Jellyfish. Marius Vlad from Collabra has already done most of the application porting, thankfully. might be interesting to see if we're in a position now to maybe more easily support landscape mode. That would be, this has been discussed for at least a year about potentially enabling that. I'm hopeful that the Pipewire and wire plumber changes will come in for jellyfish or shortly thereafter to make some of the A2DP and hands-free profile use cases work better, so we can kind of show those off. Like I mentioned, I have to sort of come up with some better support for the LIN to CAN bridging for the steering wheel and nail down what's going on with the CAN setup that we've been using. That has been discussed a couple times. This Python simulator that we wrote to sort of drive like the speed and things like that was sort of an ad hoc thing I whipped up. There are a couple of external vehicle simulators that have been mentioned. It might be nice to actually integrate one of those finally and make for a sort of fancier demo. We could do some more work on voice integration. There's things that are in the Alexa SDK that we don't support yet. I'm going to discuss those in a couple slides. The other sort of thing that's coming probably before the end of the year is the new AGL reference hardware platform, and the instrument cluster expert group, instrument cluster work, that might show up in, within the next 6 months. We might start thinking about building instrument cluster images with that, or sort of pulling in some of the containerized IVI and cluster changes from the demo that was given at CES 2020. So now on to the lessons learned part of the talk. Some of these aren't going to be too surprising based on what I've just run through. So the sort of first one on my list is that, so this is coming from the point of work you'd have to do to productize AGL. That's where I'm sort of coming from. So Pipewire and Wire Plumber, the audio policy support is definitely not complete at the moment. There's that JIRA spec about things that don't work. And if you were productizing AGL as it stands today, like Icefish, you would probably have to actually engage with the upstream Pipewire developers and invest some effort into becoming familiar with it enough that you could actually start potentially enhancing it yourself and working with the upstream team. And as I mentioned, there were definitely application changes required to work with Wire Plumber for CES, the media player and the radio and things like that. So that's something that you would have to probably do if you're coming with already existing in-house apps and getting them work with AGL or current AGL. The CAN workflow will require some development. I don't think this is a big surprise to people who have been around AGL for a long time. It comes up on the mailing list every now and again. So getting your CAN events for an existing vehicle in the format to use the LOCAN binding, that's not, it takes some effort. It's still sort of not completely 100% reproducible thing. People are still experimenting with some of the tools. Especially recent discussion has been around taking a Canoe database and what the workflow is to actually get it translated to work with the LOCAN. For the demo development, pretty much all the message definitions I did by hand. So basically writing the JSON for the LOCAN and using the LOCAN binding generator tool. So if you're a tier 1 or a vendor with a large CAN message definition, you're going to have some work there. CAN error handling may require development, at least from what I've seen. I mean, it's entirely possible that us, or at least my setups for the demos ending up in the error state is, something that's not as typical in a vehicle, but that it's hard to recover from that state seems less than ideal, and maybe we'll need to think about doing some development on LOCAN to add interface monitoring for the CAN interfaces, and potentially maybe shifting the configuration or control of those interfaces into the LOCAN binding itself. Onwards to voice support. So currently, we're pretty much, our voice support is Amazon Alexa specific. This, because of the process that sort of was taken to actually produce the voice bindings. It's somewhat understandable. It kind of ended up that Amazon were the only vendor actually engaging with the process to actually kind of come up with the bindings. And so the capabilities binding is pretty much defined in terms of Alexa Auto SDK behavior. And that's, depending on what you want to do in a product, if you're not using Amazon Alexa, you might have to do some development work, either to improve the abstraction that the capabilities binding provides, or providing some translation around your other voice engine's responses to actually make them look a bit more like Alexa to work with apps. So that's kind of, something is required there. It's not necessarily going to be the case that things are going to work out of the box if you don't use Alexa. And I sort of mentioned earlier, the voice support is not particularly complete at the moment. There's no support for local media control, HVAC, and several other things that actually do exist in the Alexa Auto SDK. And not even that it's not not in Alexa and in another voice agent or voice engine, but it's in Alexa and we don't have support for it. Sort of a part of that is that the newer version of the Alexa Auto SDK have revved some of the APIs in actually like breaking fashion. They're not backwards compatible. So there's definitely development work there if you want to update, and eventually I think AGL will get there. We're hopeful Amazon will contribute that at some point. But speaking of that, there have been no updates for the AGL support in the Auto SDK itself. I checked yesterday, which would be a week ago for people watching this. And the current release still has an integrated changes that our AGL is carrying that we've discussed with the Amazon team. And they still only support the Yocto Project FUD release. And that's a bit disappointing at this point because they don't even support Warrior, which is quite a while ago at this point. So we're able to build it still, so that's fine. But at some point, hopefully, they're going to actually start updating things faster. So the upshot of all that is that likely productization of AGL's voice support will require local development and likely engaging with Amazon, which is, I think, pretty much a requirement for that anyways. So continuing on, the next thing would be a lack of a notification or activity manager. So the Alexa viewer that I put together to actually display the Alexa sort of responses, I kind of had to do a bit of a hackish approach to start the navigation application and get it visible, because that's one of the things we added support for, was to say, Alexa navigate to someplace, and it would start the nav app. And we did have some discussion a little bit about how to do that, because there isn't currently a sort of activity manager in AGL. It's been discussed for at various SAT meetings for probably 2 years. It's not clear that for something like Alexa Viewer that putting the logic into a Signal Composer plugin is ideal, because if you keep doing that, all of a sudden Signal Composer is basically tied to everything in the system, which it's not entirely clear that architecturally that's where you want to go. And there probably needs to be, hopefully, some upstream activity on application lifecycle and activity management. It has been discussed. But if not, and you were productizing AGL as it stood today, you're likely going to need to do some in-house development along those lines. I've mentioned voice call issues a couple times already. If you're building a product with current AGL, you're going to have to debug some of the issues. It has been the case that, with both 4A and Pipewire, it does sort of work, but it doesn't work well enough that you could probably ship it in product straight off. And so, voice audio policy in general, I think, is a thing that would require, in-house development. And it's definitely the case today that I think that's true. So that's my lessons learned. Kind of close up with some comments here. So the demo platform and upstream UCB has come a long way in the last couple of years. We've put effort into making it more reproducible and hopefully more featureful. There's still lots of work to do to keep providing a useful test bed and a demonstrator of AGL capabilities. There's a significant number of people that their first exposure to AGL is seeing the green machine at a trade show, and so providing something that works well and actually shows off what AGL can do is this it's a very useful aspect of AGL, and I think it does inform us a bit on what challenges are for productization. So I don't think the effort is going to go away necessarily to actually keep the test bed and demonstration aspect continuing into the future. And so one sort of call out for assistance here. If you're a vendor that does your own custom demos for CES or any other trade show using AGL, please consider engaging with the community and working with upstream to actually get any infrastructure changes you're doing to things like the window manager or any of the bindings, get those upstream so that basically you don't have to carry them yourself. They don't disappear. We've had sort of issues like that where we had to sort of resurrect things, but getting common functionality that people need upstream benefits all AGL users. So if you're in that position and that you can actually upstream some of your demo work, or at least show what you've done to the community to give us an idea of maybe ways we could do it upstream, that would be very helpful. And I think that's kind of the spirit of AGL, where we're trying to build a platform that everyone can use to productize. Thank you very much.